Hello there, and welcome back to our video series on the topic of homeostasis. Now, in the last video, we looked at the structure of the skin. So before we move on, just do a quick check yourself. See if you can spot and identify which structures are the ones which are involved in excretion, and which structures are the ones which are involved in regulating temperature. Now, for the rest of this video, we're going to be taking a closer look at thermoregulation, or the regulation of temperature by the skin. So back in about, I think a few years ago, there was this really crazy heat wave in Europe, and you can see it here, where temperatures were approaching nearly 40 degrees, and it actually caused a number of death by heat, and such things remind us that it's very important for our body to regulate its own temperature. Even though there are limits, we have to have mechanisms in our body to try to regulate and keep our core temperature constant. Otherwise, we'll find it difficult to survive. So in this rest of the video, we'll be looking at how the body gains and loses heat, and how our body regulates temperature, and how this is a form of homeostasis as well. Right, maintaining a constant or relatively constant internal environment. So here are the textbook pages. So do you know that all of you are hot? Yes, you are heat producing machines. And how does the body produce and gain heat? Well, here are three pictures to show how the body produces or gains heat. So can you guess any of them? Well, the first picture has to do with metabolic activity. It has to do with a process called cellular respiration, which you already know about. Respiration is the breakdown of glucose with a release of energy. Some of the energy that's released in respiration is released in the form of heat. So in cold environments, your body will increase its metabolic activity. And that's why some people actually feel more hungry when they live in the cold. Secondly, muscle contractions. In particular, vigorous muscle contractions in the form of shivering. That's also another way that the body gains heat. And finally, the body can also gain heat from the environment, right? We can stand in the sun and then soak up the heat. Or food and drinks, right? I mean, in the cold, there's nothing better than like a nice hot chocolate or a nice cup of hot Milo, right? To warm up our body. Or in Russia, some people drink the vodka, and then gives them this very warm sensation in their stomach. And how does the body lose heat? Right? Please, I know you guys are probably going to just comment on this picture, but whatever. Right? How does the body lose heat? Well, the main way is actually through our skin. We lose heat through our skin, through the three processes of heat transfer, which you might have done in physics before. Radiation, right? Heat will radiate out from our skin. Convection, for example, air currents blowing across the surface of our skin will remove hot air and then, replace it with cooler air and so on. And to a certain extent, conduction, right? But that's of course less than radiation and convection. The second main way the body loses heat is through evaporation of water. For example, sweat from our skin. So when there's evaporation, then heat will be removed as well. Well, thirdly, the body can lose heat through our feces and urine. Now, if you've ever peed in a very cold country, you'll realize that your pee does it come out and freeze? No, it doesn't. The pee is at a very nice warm temperature. So another way the body loses heat is actually through your pee, your urine, and through your feces, which are nice and piping and warm. And the last way is also through your exhaled air, which is coming from the core of your body, so it tends to be warm as well. So that's another way your body loses heat. Alright, so we've seen all the different ways that the body loses and gains heat. So let's put it all together as we discuss how the body regulates its temperature. Now, thermoregulation, regulating temperature, is also a form of homeostasis, right? We maintain our body temperature within narrow limits, right? Between about 36 to 37.5 7.4 degrees. And as we remember, I hope you remember that in homeostasis, under homeostatic control, we have a few key elements, right? Remember the stimulus and the receptor, the control center, and so on. Now, in the case of homeostatic control of body temperature, the receptors are found in two places. Firstly, we have the thermoreceptors in our skin. Remember those nerve endings are in our dermis layer of the skin. And there are also thermoreceptors in the hypothalamus. Right, again, you see the hypothalamus, right? You saw this hypothalamus when we talked about antidiuretic hormone, right? Regulating blood water potential. But the hypothalamus turns out to be very important. It's kind of like there, and one of its main functions is to monitor the levels of all these conditions, water potential, temperature, and it is a control center for a lot of these conditions in the body, playing a very important role in homeostasis. Alright, so the receptors for regulating body temperature are found in these two places, and the control center is found again in the hypothalamus. So the hypothalamus compares the temperature, the current temperature with the set point temperature, and then the hypothalamus will decide to activate the corrective mechanism, and it will send out nerve signals to bring about the corrective mechanism. Now, why do I highlight nerve signals? Remember that under regulation of water potential, when we talked about water potential, the hypothalamus would stimulate the pituitary gland to produce antidiuretic hormone. So the signal that was going out there was a hormone signal, right? It was a signal of hormones. But in this case, the signal that's going out is a nerve signal. So the hypothalamus will activate and bring about its corrective mechanism through sending out nerve signals, not hormone signals. Alright, so not through hormones this time. This is through nerve signals. Alright, so once again, we're going to look at this diagram. So the set point of our body temperature is around 37 degrees. However, if you go for a nice run, which I always encourage you guys to go for exercise, go for a nice run and the core body temperature will increase. Right, so the stimulus that change from the set point is that your body temperature will increase. This is detected by the receptors in your skin and in your hypothalamus, and the receptors will send this information. So let's say your body temperature is going up to about 37.6 degrees Celsius, which is above the set point. The receptors will detect this. It will send the information to the control center. The hypothalamus will compare the current temperature, 37.6, to the set point, 37, and say, oh, we're too hot now. So what should we do? The hypothalamus will send out nerve impulses to activate the corrective mechanism. And the hypothalamus will send out these nerve impulses to effectors. And we'll see what the effectors are on the next slide. This corrective mechanism will lead to the response, which is that the body temperature will decrease and bring the body temperature back to the set point. Right, of course, the signal is sent to the receptors to ask it to shut off the corrective mechanism. So I hope you remember that this is a form of negative feedback. Alright, so what is the corrective mechanism if your body gets too hot? Well, it's a bit of a common sense thing, so we're going to go through this quite quickly. Firstly, your body will try to increase the heat loss from the skin, right? Lose more heat from the surface of the skin. So in order to do this, you'll increase the amount of blood that flows into the capillaries near the skin surface. And I hope that you can remember that requires the arterioles to dilate, allowing more blood to flow to the surface, and the shunt vessels to constrict. Right, next, your sweat glands will become more active and will produce more sweat. Alright, so more sweat will be secreted, and this sweat will evaporate and will remove latent heat of vaporization from the surface of your skin. Now, what is this latent heat of vaporization? You'll learn it in chemistry actually. The latent heat of vaporization is actually the energy needed to convert a substance from liquid to gaseous state. Alright, so there's a certain amount of energy that is needed to change a substance from liquid to gas. And in this case, there's a certain amount of energy to change the water in the sweat from a liquid to the gas. So as water changes from a liquid to a gas, as it evaporates, it absorbs some energy from your skin. Right, so imagine liquid water here. It needs to absorb some energy from your skin in order to change from a liquid into a gas. So it removes that heat of vaporization from your skin. Right? Finally, you can also breathe faster, so you remove more of the warm air through your exhaled air. Right? Finally, your body will also decrease its metabolic rate, so decrease cellular respiration, and hence decrease the heat produced, right? Produce less heat. So you can see basically what your body is doing is it is increasing heat loss and decreasing heat production. And this on the whole will lead your body's temperature to decrease back to the set point. Okay, so now for the reverse case, the set point is 37 degrees, but now you're put into a freezing environment and your body temperature decreases, right? Let's say to about 36 degrees Celsius, the core temperature of your body. So this is again detected by the receptors. Receptors will send this information to the control center. Control center will compare the current temperature, 36 degrees, to the set point. And now we're too cold, we're too cool, we're too cold. So what do? Hypothalamus will send out nerve impulses to the various effectors to carry out the corrective mechanism. And the corrective mechanism will result in the body temperature increasing back to the set point. Alright, now we're back to the set point. A signal is sent to the receptor to stop the corrective mechanism. Now, as a side point, the effectors, some example of the effectors would be like your sweat glands, right? So a signal will be sent to your sweat glands to cause them to be more active, or to the muscles in the arterial walls, right? So the hypothalamus will send out signals to the muscles in the arterial walls, causing them to either constrict or dilate, depending on whether it's too hot or too cold. Alright, so what are the corrective mechanisms when it gets too cold? Firstly, right, we want to reduce the amount of heat loss from the skin. So hopefully you recall that this requires the arterioles to constrict and the shunt vessels to dilate. So less blood will flow to the blood capillaries near the surface and less heat will be lost. Secondly, the sweat glands become less active. Thirdly, the hair erector muscles will contract, so the hair will stand up and you'll trap some air inside, so that helps to insulate you a bit more. Right, so take note that the hair erector muscles are another example of an effector. So nerve signals will be sent from the hypothalamus to the hair erector muscles so that they will contract. Right, importantly, your body will also increase its metabolic rate to produce more heat. So a higher rate of respiration. And if all of this is not enough, right, then your body will activate shivering. Now, shivering is a reflex. That means it's not voluntary, it's automatic. It's a reflex, and we call it a spasmodic, right? So uncontrolled, spasmodic contraction of your skeletal muscles, and this increases the amount of heat produced, right? So it is a reflex and spasmodic contraction of the skeletal muscles, which causes an increase in the amount of heat produced. So in this case, we are reducing heat loss and we are increasing heat production. And that should bring your body back to the set point temperature. Alright, before we end, just two things to leave with you. Firstly, I want you to go and practice looking at thermoregulation and drawing out this sort of diagram for it. Okay, so what's the stimulus, receptor, etc. If you need help, you can look at this textbook page. And lastly, an interesting question for you. You know when you have a fever, your body temperature rises above the set point, right? Above 37 degrees. But then why is it that you shiver? I mean, shivering produces heat. So why do you shiver with a fever? Well, think about it and we'll discuss in